Next, welcome to our IVJ channel. Next, continuation topic amplitude. What is amplitude? Amplitude is denoted by capital A or small a. See, for this expression, we have to consider first of all wave. Which wave I am taking? What wave? What type of wave I am taking? Transverse wave. So transverse wave consists of crest trough. Crest trough. Now what we have to find? Amplitude. So for this, see here, what is crest? This is the position line joining the positions of the particle of the medium. So first of all, this is the mean line. This is the mean line. So what is mean line? Suppose the water is at rest, still water is there. So where the transverse waves, first of all, you know where the transverse waves will be formed. Transverse waves will be formed where? On the surface of water. Transverse waves will be formed on the surface of water. So first of all, I am considering a transverse wave. So the still water is there now. So that layer is upper layer. That is still water upper layer is let it be a mean line. Now when you if you drop a stone into the still water, automatically what happens to produce waves. So at that time what type of waves will be formed? Transverse waves. Now so this is about crest. So how do you say? Clearly I am telling. So this first of all, this particle is there. This particle is there. So this particle is vibrating. So vibrating to this position. Again coming, moving away from the mean position. After reaching certain position, it is coming back to its mean position. Again, it is moving away from the mean position and reaches to some extreme position. And again it come back towards the mean position. Okay, again it is moving away from the mean position. Okay, and it reaches to maximum distance from the mean position. Now again it is coming towards the mean position. Again it is moving away from the mean position and reaches to maximum displacement and reaching towards the mean position. Like that it is continuous. That means crest and troughs are forming. So here what is this crest? It is the line joining the positions of the particle. So at different time intervals, the particle is at different positions. So we are joining all these positions. So that is called upper portion is called crest, lower portion is called trough. So first of all, the particle I am considering this particle, same particle only. So this particle is considered as first number one. Now A1, let it be A1, particle A1. One particle only, but position A1. Now the position at extreme position. Now let A to be the extreme position of the particle. Extreme position, maximum. Extreme position. And let another particle I am considering as A3. Here I am R. You can consider as C here. Let it be position A, R, this is a B, this is a C. Okay. Now we are considering three positions of the same particle, of a particle from the mean position. Draw a perpendicular from position A onto the mean line. So this is a perpendicular distance. That is nothing but displacement. Okay. So draw a perpendicular from B to the mean position or mean line. That is nothing but displacement. Here draw another perpendicular. So this is also displacement perpendicular distance. So let it be A1. So from position A onto the mean position, mean line, the displacement let it be A1. or S1, whatever maybe you can take, let it be S1. So that is displacement. B, from B onto the mean position, let it be S2, displacement. Again, from C onto the mean position, let it be 3, S3. So here S1, S2, S3 are the perpendicular distances, are here S1, S2, S3 are the perpendicular distances. Are the perpendicular distances from the points to the mean position, from the position to the mean, from the same particle, from the at different positions, from different positions to the mean position. So it is nothing but a displacement. So I am representing in terms of S, because S bar is nothing but displacement. So S1 represents a perpendicular distance or displacement. S2 perpendicular distance or displacement. S3 perpendicular distance or displacement. So out of all these S1, S2, S3, which is greater, means which has more length, which has more displacement? S2. S2 is having more length. That is called amplitude, A denoted by A. So what do we say? So this is less distance, this is less distance compared to S2. So where this is maximum displacement, this is more length, or it is also called maximum displacement. Maximum displacement. So maximum displacement is nothing but amplitude, right? Similarly, the position I am considering at D position, another time it is at E position, it is at F position. Draw perpendiculars from B, but perpendicular from D to the mean position. Draw perpendicular from D to the mean position. Draw perpendicular from D to the mean position. So this is nothing but displacement. Let it S4, S4, S5, S6. So out of S4, S5, S6, what is maximum, which has maximum length or maximum displacement? S5 is the maximum displacement. So this is called amplitude. Maximum displacement is called amplitude. Okay. So here towards the upper portion or towards the lower portion, the extremities are at the same distance from the, or at equidistance from the mean portion. So here whatever the displacement S2, here what the same displacement S5, both are equal. So S2 equal to S5, S2 equal to S5. Maximum displacement is nothing but amplitude, means maximum displacement. Okay. Now, so what is the definition of amplitude? The maximum displacement. The maximum displacement from the position of the particle, from the position of the particle to the mean position, is called amplitude. It is denoted by capital A or small a. Units we can take meter, nanometer, or angstrom unit. Units of meter. Similarly, already we explained. Copy this one. Yes, we'll go to next.